please just help people here and there individually? Is that okay? Okay, then we'll do that. Well, I would like to thank Cheryl, but Cheryl's not here. So I suppose we'll skip that part. Or maybe she's on the wire, I don't know. Anyway. Let's see. Hi, I'm Tim vanMourik. I'm not sure how much you know about me, about my work. I don't know you either. So first, point of order, mention it whenever anything is unclear, whenever you'd like to know something, whenever you'd like to dive deeper in one thing than the other. Because I would, especially with a group as small as this one, I'd like to tailor it as much to your needs as possible. Exactly a year minus a day ago, I defended my PhD thesis on the analysis of layer-specific fMRI. Basically, the analysis, that's indeed my thing. I know nothing about scanners. My work starts whenever the images are done from the scanner. Just a quick raise of hands from you. If you're saying I'm more of a scanner versus an analysis person, who would say more of a scanner person? Yeah, more? Who would say more of an analysis person? Okay, that's a little 50-50, that's good. That's good to know. So, I'm going to talk a bit about layer pipelines. Well, John already started with that. I would like to dive a little deeper here and there. We're going to look into some code examples, but I'm already going to tell you that I'm not going to solve all your problems. Hence, the subtitle is going to be an incomplete and inexhaustive pipeline that does not solve all your problems, but I hope that it's going to get you started with at least something, and that it'll touch upon all the difficult parts of laminar fMRI. Let's see, my mouse, yeah, there we go. So my PhD in a nutshell is I developed some tools, some new methods. I think John already touched upon some of the problems, like registration, co-registration of images is a big problem. Obtaining a laminar signal is a big problem. So that's what I try to solve. I wrapped it in a toolbox that we'll touch upon later. And I developed pipeline tools to easily build and construct a pipeline with these tools to come to a complete end-to-end analysis from the images straight from the scanner right up until the layer time courses that roll out of it. And that's also basically what we're going to do in this presentation. A little bit of more expectation management. The goal is that at the end, you will know how to potentially get a way of getting started with a layer pipeline based on an example. We're going to focus on a single subject. That data is all available here. The group analysis is also available, but I don't think we've got time for that. I'm only going to show you a way of doing this. This is all developed with my MATLAB implementation. If you prefer NIRES or FreeSurfer or Laney or whatever, I'm all cool with that. So it's going to be a suggestion for a start, a suggestion for sharing pipelines. I feel it's always very important. Cheryl's now just come in. At the beginning, I thank you for inviting me here, but moreover, I really appreciate that you share the vision that it's important to just talk to each other about the pipeline that we've got and see what common problems we run into and to see if we can solve them together. Something about reproducibility by design, if there's time for it. I hope to dive into a little bit of my study, but given the time, maybe we're not gonna get into that. But there are no results anyway. So, um, and yeah, maybe there's time to talk about null results in the literature, but given the time, I'm not sure if point 3 is gonna work out. Anyway, there are many different analysis tools for fMRI analysis and for layer analysis. I want a very quick raise of hands. Who's ever used FreeSurfer? Yeah? Brain Voyager? No? Laney? Open fMRI analysis? Maybe. NIRIS? Okay. SPM? Yeah, FSL? Okay, MATLAB in general? Most of them. Python? A little bit? No, NiPipe? Ah, no, not hardly NiPipe. AVNI? All right, and everybody's working custom tools at some point, probably. Okay, so layer analysis and analysis in general is very often the question of where to start and how to mix and match different solutions that are out there. When I started this, and well, over the course of my PhD, what I envisioned for an ideal pipeline would be something that is very openly available, that you could very easily share with others. The code, the data, and well, the combination that will be reproducible for other people, but also reusable and very easy to exchange simple blocks by, well, progressive insights. Ideally something version controlled. Who is actively using GitHub? Not so many people, but thank you for raising your hand as well.
I'm used to GitHub in such a naive way.
That's fine. The naive way of using GitHub is the best, usually. Don't worry about that. I just want to, yeah, I'm trying to get a better impression of my audience. That's all. Right. And my hope was to get insightful analyses at the macro level. So then I was like, well, right, one of my gigs is to give animal acronyms to my tools. So I wanted a graphical interface for reproducible analysis for workflow experiments. It's not the best acronym, but then we got, well, with this application, and let me show you that straight away. So I set up, I ran one just experimental study. It was about layers and it was about visual attention. So there is this project that I just called Layer Attention. And I wrote a web application that allows you to visually build your pipeline, your analysis pipeline. And this is the pipeline that you see here is a graph of all types of functions that basically represents an entire layer analysis. So during this hour, or what's left of it, we're going to some of these examples, to the pipeline and to the different parts of it, and discuss some of the problems that arise whenever you're doing a layer analysis. So let me very quickly show you the idea of the graphical interface first. Whenever you've got, well, Cheryl, what's your favorite function? Your favorite SPM or your favorite your favorite AVNI function?
My favorite AVNI function is
so alineate, that's probably for registration, is that right? So let's see. Probably in the pre-processing, there is at least my version of realignment, or is that the same thing? Is it co-registration or realignment? 3D alineate. Okay. Then it's not, let's see. Then it's not this one. Then it's not the realign one. Then it is probably, oh wait, there is an entire header of registration. And I even wrote a wrapper around ANDs. So this might well be a wrapper around ANDs registration. So the idea is that every box represents one function in your entire pipeline. And that can be registration. And let's see, with the registration, you often have a reference value, and maybe you have a mask based on which you want to register, and maybe you've got some other things. So the idea is that you can, well, wire up the input and the output arguments. And let me quickly delete this one, because in the current pipeline that I've got, I already have a registration set up. I'm usually fond of the boundary-based registration from the FreeSurfer package. So the idea is really quite simple. From another function, which is some realignment function, there is a link drawn to the registration function, and that's what it's going to do. Then whenever you drag in a new function, it'll automatically create the code for it. So there is the realign function, and it automatically creates the MATLAB code specific to my current toolbox that I'm going to show you in a moment, that is needed to run that function. So, well, like I mentioned, sorry, one in-between question. Who by now managed to log into the server? Okay, most of you. Oh, we're almost there, almost there. So I think we're quickly going to jump to the data that's on the server. Then let me see. Where is it? Which one is my VNC session?
Yeah, so why don't we just take a 5-minute pause to like transition to being on the server then, right? Start working on data there.
Yeah, that's fine.
Just so we don't have to
Let's
process too much.
see. Could you help me out? Which one is here is the VNC session? I had it not all that long ago. Oh, right, it's there. There we go. Then let's move password. Let me quickly figure out what my password was again. Yep, there we go. Protocol. Yep. Is that?
They're long passwords.
Yep. Yeah, there we go.
And so then you just want to get your screen to a state where you want everybody to be, and then just freeze there. Then we'll get around the room and make sure everybody's in one place, and then everybody can definitely.
Yeah, that's very structured.
Yes.
I like it.
So just like minimize MATLAB, like everybody wants to be in a terminal, you'll show them how you launch MATLAB.
Yeah. Okay. Let me quickly see where I am now. So for all those that are on the server right now, could you please CD?
Wait. Oh. I don't think everybody's there. So we're going to freeze in this moment until everybody is in a terminal ready to type. All right?
Right.
Time?
Cool.
Right. So
then
one is, all right, we just need to launch that terminal. Yeah. Doing that. N-1.
All right. And I'll pause for Is that? Yeah. Yeah, please.
Did you have to? So I didn't do anything like that. So you just had to type.
The MATLAB string.
Yeah.
Yeah.
So
For
maybe for this afternoon, what I'll do is I'll add
this
paths so that
that's probably easier.
so 27.
And probably programming like 15, 12, even 12 might work. I ran this at some point with 2018A, I think. So I'm most certain that it works with the latest version. So that's why I'm just gonna try this and we'll figure it out.
So today our star is going to be 17B until we find out. That's not true.
That's right. And this is all stuff that I need to add at some point in the README of the file.
Right. Which version? Yeah, the last time I actually kept up in the math.
All right, I think. Oh wait, no, n-1.
N-1.
Is that right? Okay.
We got 9, man.
Okay, yeah, that's a very good principle.
Otherwise, I'm a very easily distracted person. What I can do is take a few static notes here on the board for what people want to do. So I'll just do your
Yeah.
off-screen.
Okay.
And
That would be lovely.
so you're going to, so we have a persistent misery.
So when we're on the server, we open a terminal and we cd, we change directory to /home /scat84/share /cdrf 2019 /hands-on data /vanMourik /single subject. Yep, beautiful. Then we open MATLAB, and ideally we open the latest version, because which is 2017B here, which is located in /opt/local /MATLAB 2017B /bin /MATLAB. And you might want to add an ampersand if you want it as to undock it from your terminal. What's that?
I'm not good at drawing ampersands. I never have been. Do you guys do this just for
Yeah.
ampersands? Big and. Optional. Here you can put it as an ampersand.
And there's a little bit of a long tail there.
Right.
This is optional. Let's see. Oh yeah. Yeah. I see a server there. That's brilliant. Yeah.
We're struggling with one language situation over here today.
Language. Okay. I lost my screen a moment ago. Yeah, there we go. It's back on there. So we're in MATLAB. Oh, I should have done that. Let's see. Right. In the MATLAB, probably your MATLAB started in a single subject folder. Then the toolbox that I wrote, the MATLAB toolbox, is called OpenFMRI Analysis. You can find that right here. It's also online at GitHub/TimVanMourik, which is just my full name, /OpenFMRI Analysis, for whenever you want to download it not on the server, right? We go there, we quickly go to that folder, we open the install toolbox file, and we press F5. Yeah. And then it should do something like this. Which is basically just a simple message. Hello, you're welcome to use this. Please remember, like any software, there is some continuous development there. I see some puzzled faces. Sean, is there?
Sorry, where did you install?
You open this
Right.
file and we're
So-
figuring out the name.
Yeah. That's right. You can just open it. You don't have to open the thing. You can also just run it from anywhere. But that running that file takes care of the path settings. Okay, that's all.
Yeah, so tell me what it does. So
It
running this file,
literally
it's
just
path settings.
adds the path without you having to figure out which path to add. That's all. Quick raise of hands. Who does this work for? Yeah.
Define work.
Define work. If you can see this little warning sign, then it works. You can switch that off, by the way, but we're not going to do that now.
Okay.
Okay, that's.
Oh, little walkie dude. Is everyone see that?
Oh yeah, yeah. This is ASCII art.
All right, so you see ASCII art.
So exactly, then you did it correctly.
All right, so you need to pause here until I see ASCII art on the screens.
Uh-huh. Can you be my eyes and ears, Cheryl?
Oh,
Is that working?
Sean, do you have ASCII art?
I think so. It's just another one big.
I hate the way these come in. There's so much going on.
It's MATLAB. Yeah. Can't do it. Okay. Now, there's not really a shuffle. There is just a pile of dirt.
Oh, it's a pile of dirt.
Which
Okay.
is shuffling up or something.
The success is lower.
Right, beautiful. Now, let's see. The script that we just built online. Sorry, can I move on again? Yeah, I think so. Yeah. Let's see. How do I get my previous screen back? Where did my presentation go? Yeah, there we go. No, not Safari. There we go.
Oh, your screen is so nice. Oh, that hurts. How does the person make that? Yeah. Just hit the little green button.
I think we're all on the same page. Beautiful. Then let's move on.
So, is it
sorry?
because when we hit the little red dye, MATLAB asks us if we'd like to change to the folder or add to the path. People have made both choices.
It's fine.
Okay.
It shouldn't. So the thing about the script is that it realizes what path it needs to add for the functions to run, and then it should take care of itself.
Okay.
But that toolbox is just a toolbox of all different functions that at some point I wrote that is now loading. What you would like to do is use the separate components of that toolbox and wire them up together to make that pipeline. So this particular pipeline that is starting with realignment, then, well, we're going into some registration, some boundary-based registration, then we go into some other parts of the pipeline. We make some movie file, we do a lot of things, and let's see if there we go. That script was saved under vanMourik, single subject, subject 11, which is just a random subject that I took. I think, oh right, the reason I took 11 is that it's my own brain, and then it's easier to share in terms.
I give myself permission to share.
Exactly, to do these permissions. And there is a master script.
Do you want us to open
And you can open it, yes, please.
that? So single subject 11. How did you generate that script?
And that script is generated from, let me show you if I can get there. That script was automatically generated by this application.
Okay.
So that application URL is found at giraffe.tools/ let's make this the alias of it, /workflow / Tim vanMourik / layer attention. And what's that? This long?
URL.
Right. But this entire workflow is also found on GitHub. So in the UI, there is just the oh, come on. Oh, no, I don't want to share. It's identical. They're aliases of each other. So this entire pipeline is saved here. I can already add. So Cheryl asked, where does that master script come from? Well, that is saved here. I'm not going to go into details right now because I really want to. I don't necessarily want to talk about this application that I wrote. I think this whole hour should mainly be about the analysis and the steps we go through rather than about the application. But you can ask me about the application if you're interested, of course. Anyway, what I wanted to do is to show you a little bit more about, come on, the different parts of the pipeline. There we go. And I wanted to show what, to talk about and to discuss which parts of the pipelines are important. Well, I think John already started with that this morning, and he already started talking about the necessity of analyzing your functional data in a space where you also have some cortical surfaces, such that you're able to determine the layering of that volume. Is that right? Has anybody ever done any layer analysis before and done this cortical layer? And has anybody done co-registration before? Yeah. So the way we tackle this problem in Nijmegen at my lab, it was a very naive way. I've heard several people like Renzo and Cheryl and many people doing fancy things on the scanner and making sure that there is anatomical contrast in the EPI, which is, well, your take-home message, I believe. What we did was a boundary-based registration. Does that ring a bell to people? Ish. Basically, with a boundary-based registration, you take you take your functional data and your anatomical data, but only the surfaces that FreeSurfer generated on the anatomical data, and is trying to map them to the same space as best as possible. What you haven't figured out then is that if your functional data is slightly distorted because of the API readout, they might not overlap perfectly. So one of the things that I implemented was a recursive boundary-based registration, which is a new method that does a boundary-based registration on the entire volume first, then basically chops it in two and does it on both halves, and chops it in two, does it on the individual halves again, and then make sure that that the whole registration is smooth, such that your anatomical volume gets like a little bit warped towards your functional volume. Anyway, that's what this part is doing, and what this function is doing. And let's see, if we go back to MATLAB, we can look that up. So what were the functions called? If we Control F, sorry, or Command F, Control F. How do I search in MATLAB? Option F, Control F. Oh, okay.
You can do it from a menu based thing if you go to like edit, find.
Oh, right, yeah. My hotkey disappeared. I'm sorry about that. But if we look for the BB register, there we go. Then we get this one part of the entire script that does the registration for us. So now, how about I just quickly copy that to a new file to be very explicit about what it's doing. Control V. Oh, also my copy and paste hotkeys. All right, now let me quickly Control C and Control V this, and nope, that still doesn't work. Come on.
The standard
What?
when you're not allowed to start on a Linux machine. So
What's email?
Alt W.
Alt W. That's what. Alt.
No, no,
No, I love the suggestion. And the paste. Does anybody know Emacs commands by heart? Anyway, we can also just maybe we're going to drag it into the editor. Maybe that's easier. Yeah, that works. Okay, so this is just when I was writing this toolbox, I didn't want. I definitely reinvented some wheels, but I didn't reinvent every wheel. So I wanted to be able to implement my own things in MATLAB, but also to be able to run things from other packages that were that other people developed before. So there is a command, and whenever I wrap the package, I usually call it every function starts with TVM, which are just the initials of my name to know that it's part of this package. And the use BB register is that I'm using something from another toolbox. Now this might actually crash because FreeSurfer is not installed. Oh no, because SPM is not installed. Was SPM, Cheryl's SPM installed here on the?
Not on the list of things that people ask.
Damn.
That can be done quickly if you just want to take a 5-minute break for a beverage and catch up in a conversation. You SPM on there for you.
That might be.
All right.
Yeah, I'm using all my.
5-minute brain break.
We'll get SPM installed for you.
Okay, then then we're very quickly going to install SPM. How can we do that? I don't know what. Let's see. I don't know where to install it. So that everybody can see it.
Yeah. We've been discussing
So. So whenever you implement a new toolbox, but you're relying on the software, there is always the danger that here and there you get back to dependencies. There are any intermediate questions? That is. Oh, that's a good one that you mentioned. That is on yeah, that's the crash close. So now we're at the same crash. So I didn't manage to test also. In the meantime, as SPM is being installed, I'm quickly going through the rest of the pipeline because we can do that just in abstracto. Because the whole idea of the graphical implementation is that you can very easily separate the abstract pipeline from the code pipeline. What I like to do is to write little sanity checks of the files that are produced. So after the BB register is done, you would like to check, well, did it perform well? So I wrote another function which automatically makes a movie file from a volume and from boundaries. And the boundaries in this case are the boundaries as determined by FreeSurfer and the register boundaries that we produced. And the script automatically made these for us. So, and in the, let's see, in the little box allocated for the boundaries, we wrote to write the output boundary file, sorry, the output movie file, let's see, to co-registration/bbr.avi. So if we go there, if we go to a file browser, no, let's see, if we go with the terminal to our single subject, cd subject 11, and I just said that the file is located in co-registration/bbr.avi, then co-registration/bbr.avi. There you go. It's there. Oh wait, I've got a CD, so I've got a CD to a folder. What is a standard Unix media player? Do you know? For movies? VLC? VLC? No. Brian and Cheryl, is there any movie player, media player on Unix? That's,
Sure there are.
let's see, applications.
Finish that 5-minute pause so I can cue this.
Okay, sound and video. Let's first try and check this. Then that's something we can just. Let's see, if we go to the videos and if we add a local video and we go to the same path, that should work, right? But let's see, on computer, right. So it is /home?
Yeah.
Right, then we're in /home. And then where did we need to go again? To Scottrade. Why is there, oh right, there we go. Yeah, sorry, we're in the root now. Scottrade full, share, CDRF 2019, hands-on data, vanMourik, single subject, subject 11, co-registration, and there is my bbr.avi. Yeah, does it run? Yes, there we go. Okay, that's the first view at my data with boundaries on top of it. Brilliant. Cool. First thing that worked. Anyway, so
Maybe
yeah.
pause here. So I can, so you could just install if everybody else can get that.
I think that's a very good idea.
You and Brian figure out and then you guys, the class, will talk me through the success that just happened up here.
Sorry, we're doing things in parallel.
All right.
So
Underneath the hood, in the process about to start working, boundary-based registration happened. And so the idea of boundary-based registration is that you have some anatomical gray matter and some functional gray matter, and they don't line up with each other. And you apply some kind of an algorithm. And when that algorithm is done, the anatomical data, as Tim said, has been warped to match the functional data. So boundary-based registration can be either linear, rigid body, or nonlinear. You make a choice when you do that warping. Do I allow my anatomy, that glue, do I allow that to flex as I do the alignment? Or do I make it linear with the same shape? So when we have Tim back, we will ask Tim if it was a rigid body alignment or a nonlinear warping. But the process was to go from two images that were not perfectly aligned. And does anybody know or want to describe what is special about boundary-based versus other types of registration? I know John's the one who taught me what boundary-based registration is. We have a non-presenter a first crack at it, but yeah, so just a conversation about what is boundary-based registration.
So if we look at the lines that are placed on the top, Essentially, we want to optimize so that either side of that line is kind of where the gradient of that line is. So in other words, with the yellow line, it's quite clear to see that one side of it is quite dark, while the other side of it is lighter. And there should be some optimal position where that difference over the entire brain in his first step is greater. And then he goes and does it at more local.
Yeah, and that, and he described everything else, and so I just want to make sure everybody's on the same page about what boundary-based registration, and it's putting your boundary in the right place to optimize the contrast across the boundary.
Yeah,
And the question for you was whether the algorithm was how many degrees of freedom you had, and if it was a rigid body or a non-rigid body registration.
Okay. I'm going to answer that question in 10 seconds, but first, the trick about boundary-based registration is that API images don't have enough gray matter, white matter contrast to create your boundaries on top of, but it is good enough to figure out where the boundaries are if you already have the boundaries created on an anatomical. So then you can do that very coarsely in the first instance. But then if there are still anatomical malformities, you can iteratively apply the boundary-based registration on separate parts. Now, whenever you do that, whenever you do a rigid body registration on separate parts, but then you combine them, and you do that a couple of times recursively, iteratively on smaller parts, then effectively the fact that you do rigid bodies on a very small level, but you do that many times, make sure that you've got a non-rigid body registration at the larger scale. So the answer to Jared's question is, in principle, the single transformation are a rigid body, but effectively the larger transformation is non-rigid body. Yeah, please, Tyler.
Does your method for recursive boundary registration, I think I see that you have an option for a mask. Does that basically weight that area as more important for the localized?
I think at the moment, that mask option is a binary mask for voxels. Yes. So not just more important, just uniquely important. In the meantime, we solved the the SPM issue. So that's what I quickly wanted to write down, and now my session here died. So depth result. Let me quickly log in again. No, not that password. Oh, sorry. So if I ls to /opt/local/spm, oh, sorry, spm, and there is spm 12. And if we add that to the path, and I'm going, oh, would you like to write it down? I will start it reading. Yep. So add path, no, add path without, yep, there we go, without any. Then if we add that to the path, then now some function like some SPM vol should be defined. That's right. Okay. So now, if we, for example, make, what's that?
I think I wrote it the hard way.
You wrote it the hard way. Okay. Oh, right, but a gen path, no, never mind. Not important. So let's see. One of the let's go to the recursive boundary registration straight away. If we can find that TVM recursive. So on line 128, and there are many options, but you don't need them. Now this should work, but I haven't tried it. But if I've got the recursive boundary registration and I drag that to the command line, then this should start to do something. And indeed, it's computing very hard now, because it's normal boundary-based registration already takes like 10 minutes-ish. Whenever you're doing that recursively, well, it does it over and over again. So it might take a while. So I'm going to kill the process for the moment. Right, and now in killing it, you already nicely see the recursion here, because I killed this one, but then it's calling itself several times here, which is basically the proof that it's actually doing a recursion of the boundary-based registration. Anyway, that is just a way of solving the registration problem. There are downsides to this. It doesn't always work. You might need to fiddle with the settings a little bit, but that's one of the take-home messages of this course, if it's up to me. Layer analysis is very detailed. And that means that settings for one subject might not be the best settings for the next subject. Therefore, I really like to have many of these little movie files and sanity checks here and there in between to continuously probe, like, is it correct what I'm doing, right? Yeah, John.
What kind of parameters would you change for the subject?
Whenever you're doing your recursion, you're going deeper and deeper. Well, basically you're making the volume of registration smaller and smaller, which allows for, well, more overfitting at the small level. So that's the most important one, the size of the recursion. It's not the only one. There are also, so depending on the contrast, you might want to change, well, that's not from subject to subject, but one of the things that's very important, let me grab the video again. Gray matter, white matter contrast in this API is, well, the white matter is clearly darker than the gray matter. If that's the other way around, if you were to have like a T1 weighted API, for example, the contrast flips. So there is a flag that for like reversing that contrast to be, well, because otherwise it's going to look for the worst possible registration instead of the best registration. So it's these type of parameters that are quite important to set right. Is there anything more about that you'd like to know, John?
No, so you expect the results, and if the registration doesn't look good, you might change the steps.
Yes. So to give you like a ballpark estimate, for the study that we did, I had 17 subjects, and the settings in this file worked pretty good for 13 out of 17-ish. I haven't found any way of doing that automated all along the way. If you find a method like that, then you've got an instant publication. Right? Would you agree?
Oh yeah, if we had a proper cost function,
Yeah.
But I guess the question is, yeah, you would inspect the data, change the level of recursion on a per-subject basis of some subjects.
To me, layer analysis is a lot of inspection of the data and changing parameters, cost function parameters, whenever needed. Yes, that's right. Okay.
Can I ask a follow-on question to that?
Yes.
Which is, how do you inspect the data efficiently and fairly? I'm doing registration, subjects data, and how do you
Yeah.
know when your registration?
When is it? What is good enough?
Is there a metric you
Now, I don't have clear metrics. This is really like hand wavy. The only thing I can say is that whenever boundaries clearly moved out of place, whenever something is clearly wrong, well, then I reset the parameters. But what is good enough? What is right enough? Well, the tricky part is that if there were a clear metric, then theoretically I could write a method that optimizes that metric, to make it happen. Fact is, I don't have that metric.
And this is one of the conversations I would like us to have for the next couple of days. It's like that metric should exist. For example, if if we're looking at it by eye and we're saying this isn't good enough, we're looking at something. There's something about our data where we're saying yes, no.
Yep.
And as I've drawn it here, we're looking at it, or if you have that movie, the boundary studs, we're talking about boundary-based registration, and let's try to do it. Like the metric you're calculating is optimizing the contrast across this boundary.
Yep.
And so human observers can look at that and be like, oh, good, oh, missing, oh, oops, right? So what I've been on a quest for in my life is we kind of know what the metric is. We know that we want all of the functional gray matter exactly all on top of the anatomical gray matter.
Well, we know it approximately.
Well, but
right?
Could it be known? Okay, nothing
could it be known in principle?
But in principle, and this is why I was harping so bad on the T1 weighted EPI. Like if, and it's not true, but if our EPI were so good that we could segment them, then we could have the segmented gray matter in the EPI, and then the segmented gray matter in the anatomy. And we would know we had done it right when those were exactly on top of each other. If we had a perfect match, perfect segmentation of the EPI, perfect segmentation.
Yeah.
And then surface node by surface node, you could compute here, my gray matter is 100% overlapping, here my gray matter is 50% overlapping. And we could come up with, it would be a spatially heterogeneous metric, but it would be an absolute quantifiable metric that you could optimize at each location. Is my gray matter perfectly aligned?
So the best metric that I can think of is already the metric that is inserted in boundary-based registration, because it is looking for, well, exactly that surface detection in your vine.
Yes.
Whenever your boundary-based registration breaks down, there are all sorts of problems. The contrast is too low, or there is just this extra region. Let's see, what you can also see that the contrast here is just clearer than here. It's very spatially heterogeneous. There are ways, I suppose, of like measuring that and taking that up in your cost function, but it requires many degrees of freedom. And I wouldn't know. I think it's going to require so many degrees of freedom that there is a massive risk of overfitting. So I think that by sight is the best we can do for the moment. And I think that is fine.
I disagree on both counts.
Beautiful.
The next couple days, right?
So I don't think Sorry, no, please, tell me.
No, I think this is the conversation, because I think reasonable people can disagree about what is achievable with a given data set.
I agree.
So I've stopped doing depth-dependent fMRI until I can have what feels like an absolute marker of my gray matter in my eye. Because I'm so sick of looking at my data and not knowing my registration is good enough. Like Renzo's patience for manually drawing boundaries on these gorgeous basal data is astonishing, but I've sworn off I will never draw a boundary.
Yeah, same here.
Right? So then what we say is like, I can't, it needs to be an automated process. But the problem we have is, where is the metric that's reliable enough to drive that process so humans don't need to intervene in the process anymore?
Why does that have to be? I would find it astonishing if someone went to a lab that was working on calcium imaging and we were looking at spines, and someone said, I'm not going to work on looking at this until there's a program that does it.
The reason I pause is because I believe that there is a metric that can automatically, that it is achievable to get a reasonable gray matter marker in every experiment. So I pause because I believe that pulse sequences will solve that problem. But I agree, absolutely. Like, if there weren't a ready pulse sequence solution, no, we shouldn't walk away from science.
Right.
Right?
So
that's what I'm saying. John.
Sorry, yeah, please.
One issue is that there is no match. So these surfaces are not going to match the surfaces are right. And so it's all about managing how much error you're going to tolerate.
Is
Exactly.
that true if we're doing non-rigid as well as rigid registration?
Yeah, so the other problem is when we define the cost function, it doesn't just have to be something that we can articulate what it is. The registration is perfect. It also has to, the cost function, the height function itself has to be something that can optimize it. And a lot of these cost functions, you might articulate that. They don't lend themselves necessarily to optimization. They're just lots of. And so I think that's one of the nice things about what we call it recursive.
The recursive.
Yeah, there's limits to volume, as long as volume. Yeah, so I think it's also a question of how do we articulate a cost function. I will also say that Q stars, gosh, gray white contrast varies dramatically, and for good reason. It varies because we know that the Q star tissue is one tissue event. So one folds the next, it's a very different contrast. I think Q stars just too challenging. It's possible that we might be able to have as some construction takes to help but as to say, yeah, I do wonder. So I think this is a tough problem. I think this is a tough problem. I mean, if these two were kind of directionally matched, I think it's going to be.
I agree 100% with the local minima, and the only thing I would like to add is that you can say, right, what's good enough? Well, 1 millimeter, yeah, that's a third of the size of the cortex. So 1 millimeter is not good enough. Well, 0.1 millimeter, is that good enough? Well, you see where I'm going? Maybe that's still not good enough, but then 0.01. It's an infinite loop that will never be matched exactly.
I'm trying to say
So.
And
No, also
I'm certainly
T1.
not arguing that T2 star contrast would ever be enough. I'm arguing, as I interrupted you this morning, to say if you don't need the scanner with an image that has T1 contrast to support your registration down the road, you missed an opportunity to come closer to an objective metric for guiding your registration.
I have to admit the T1 API takes a lot of work. It might not be perfect, but it's like the best that we have.
And I don't have your optimism about being able to segment my T1 APIs.
Well, actually,
But even if I can't segment them,
you can't segment it.
So
You don't have to be so bold about the segment. It still help guide the registration to give you some sense of where the boundary should be. No,
So one of the things we did, where we also used that T1 weighted API strategy once, and that is, I agree, that's a much better contrast. But then we still use this recursive boundary registration and just used FreeSurfer with the recursive boundary registration. But then, well, with the same contrast, and because the T1 contrast is so much better, the registration was a lot better as well. So, yeah.
My point exactly.
I
We do
agree.
agree.
Well, I still disagree that that's perfect,
Wow.
but
I
but I
didn't say
agree.
it was
But
perfect.
if you think that's good enough, then sure.
I didn't
I
say
think
it was good enough either, but I think it is better.
I think our goal should be to minimize as many noise sources within reason, and I think it is a reasonable at some point. If you can't limit a noise source, then you should boost your signal source, for example, by acquiring more subjects, for example.
And one last thought, registration. I think it's important to talk about this because this is the most challenging step.
Yep.
So I think it's deserving. One goal idea, right? So this T1 weighted API is nice. I think that is quantitative, T1s. Get rid of the T star contributions, but also kind of bold-weighted flash. So for example, we're just talking about the point script function. There's ways to get flash undistorted, bold-weighted, exact same readout notice distortion. And these are one because you can get motion, exact contrast match to the bold data. And this can also be like a nice sanity check. So T1 weighted APIs, bold weighted flash, everything in between. These can really help. If not only do you want to calculate the registration, you can trust it where you can. And so that's another piece again from the 80s. I think I'm sorry, 90s. We used to do like T2 anatomical, but I think the T2 star anatomical is. And you can also start to see and appreciate how you can do like a field lifetime and see how difficult it can still be to find that order. So it's another kind of a tool in the toolkit.
Yeah.
If I can just
Yeah, please.
make
Tyler
one
first.
small caveat to both of those methods actually, is that both of these scans are really, really helpful if they look great. Unfortunately, unlike EPI, which is supposed very, very quickly, you don't actually know if a subject moved during those scans until afterwards. And I find this very frustrating. And unfortunately, I see no possible way to really find this out without some kind of optical motion tracker or something.
The head case is a nice.
Well, nice. yeah, it works. We've done that.
Oh yeah,
It's,
but it's usually kind of tolerant.
Yeah, we've been using these inflatable pads as well, but I haven't seen anything that limits your movement in every single.
Oh, people are going to, they're going to move it.
Yeah, and any acquisition that takes more than what's our threshold? 10 seconds?
Yeah, just a second. I think we're not yet at the stage of doing these high resolution scans, but hopefully, for this neuroscience application, get subjects. I think a 10-minute long flash scan, you've got a pretty good shot at getting. I think it's one of the things. Yeah.
So my issue is not necessarily that people can move, because if you could notice it, I would be perfectly happy to say, oh, you moved, let's go back to it again, or let's stop it halfway through, etc. My only comment was that oftentimes with these two particular methods, I don't know until I get on my computer a day later and say, well, that's frustrating. But it kind of goes towards what you were saying. It's like you wouldn't feel comfortable getting out of the scanning session unless you had these as reference, right? And then if you think you do, and then you come back and you don't, then unfortunately, I don't see a way around this.
Right, we lost the data set, or.
But then you're left with trying to make use of T2 star data without the perfect tools that you would like to have. So I think you still little bit on some of these tools that Tim's talking about.
There are data sets in our lives that just do not have the ground truth that we would like to have
Yep.
to be able to view a quantitative measure for our limits. And so then what do? We do our best, we inspect, we make a gorgeous movie. So we've been discussing vibrantly on your time. So if you want to give us the 3-minute wrap of our key take-homes, it is lunchtime.
Yeah, I know. I was hoping to talk a little bit about layering. Let's see. What's the best way of discussing that? Let me give you like a quick overview of that. One of the things that John mentioned in his talk was that people have been, using different, I can draw here, right? So this is not a normal, okay. Oops, just checking. One of the things people have done classically is find different, cortical layers, at least something approximating layers, and interpolating the volumes at those points. One of the things we've been experimenting is doing that slightly differently, not by interpolating, but by means of a spatial regression. So one of the things you could do here, do you have like...
I feel like this is important.
Okay.
And let's just have a group decision. What if your after lunch presentation is not the same as your before lunch presentation?
Mm-hmm.
And if your after lunch presentation is layering into spatial regression, which we've been recording this whole time, and we will edit down to the key useful points. So are you guys willing to, while you're at the scanner, something different happens in this room than what happened right now that you won't be there for, but we will capture it after lunch. It will be the layering part of the story.
Okay.
And those videos will become available after we clean them up and make it all at the end of the day. So then we get to
all right, then I don't need to do this in 2 minutes, but...
No, it's too much, and it's important.
It is important.
So let's take our after lunch break now, like we're supposed to. And at 1 o'clock, a chunk of your time will again be eaten by getting the other half of the class on the server.
Yeah.
But then you'll be able to spend the time talking about
Cool.
layering.
Then we'll do that.
Capture it, we'll share it. This is okay.
It's perfect. Yeah, I like that way of winging it.
It will be a bit of a working lunch with John's permission, and food is out. It's just over there. If you would like to just have a conversation with John about the chunk of slides that he didn't get around to this morning on
so we come back here.
Back here at 12:30.
And then if we want to go back to the scanning session, we go back over there.
Well, the second scanning session. All right, this is the plan. Go get your lunch. You have an hour-long lunch break.
Yeah.
If you want to spend half of it back here talking to John about that, you have 25 minutes to eat. That will all end at 1 o'clock, at which point all y'all will go to the scanner, and then you will start talking about the second half of the stuff. So lunch break, optional working lunch in here at 12:30 if you want. Enjoy the fresh air on your way across.
Yep, sounds good.
All right.